So in the last class, we were talking about the tank circuit. Anybody can tell me what is a tank circuit? A tank circuit is a circuit having an inductor and capacitor. And in this circuit, for some time, we apply a DC voltage to the capacitor. After that, we connect this capacitor to the inductor. And you have seen that the signal you will get in this circuit will be a wave. Okay? And practically, the wave will be like this. Now, what is happening here? As time is increasing, your signal is becoming zero. And there is a frequency for this circuit. What is the formula for frequency? Can anybody tell me? 1 divided by 2 pi square root of L C. Clear, all of you? We have discussed this in the last class, right? Now, what is important is that our signal like this is a problem. Why? Because we want a perfect signal should be like this. It should be always present. So what is the way? We have to add one amplifier. Yes or no? What amplifier will do? In the output of this tank circuit, there is loss. This amplifier will take care of the losses and you will get a continuous AC signal. If you add amplifier, this amplifier may be a op-amp, may be a transistor, then this complete circuit will be called as active oscillators. What is oscillator? A circuit that generates AC signals of different frequencies. For example, this LC circuit or tank circuit is an oscillator. But if you will add an op-amp, it means it will be active oscillators. Now let us come back to our topic, to our slides. In the last class, we discussed about different types of oscillators, and today we will talk about other types of oscillators like RC feedback circuit. What do you mean by RC? In place of LC, the example we discussed just now, in RC we will be having resistors R and capacitors C. There are various models that we have. For example, Wayne bridge oscillators, phase shift oscillators, and twin T oscillators. Fine. Now, which one to be used? It depends on the frequency you need. For example, up to 1 megahertz, we use RC feedback oscillators. Is it okay? Now, the Wayne bridge oscillators is famous among all these RC oscillators. So we will not discuss all of these. We will discuss only Wayne bridge oscillators. So this is the circuit of the Wayne bridge oscillator. Okay, we have got amplifier. You know why we need amplifier? Amplifier is needed so that losses which are there in the oscillator circuit can be compensated. And this is the formula for the frequency in these oscillators. As you know, what is the input to this circuit? Only input is DC volt. Can you say this? No, this is your output voltage. You will apply some DC volt here. Okay. And what is the output? Output is the AC signal. And what is this law? FR. FR is the frequency that you will get from the circuit. And what is the formula? 2 pi square root of R3, R4, C1, C2. this is R3, this is R4, this is C1, and this is C2. Is it okay? So what you should know, what is important for you is the circuit and the value of frequency. And if you will use R3, R4 as same value R and C1, C2 as same value C, then the value of frequency will be 1 by 2 by RC. Now, what will be the value of R and C? It depends on the frequency you need. If your requirement is 1 kilohertz, R and C will be different. Then the values, when the value of frequency will be 1 megahertz. So this is the purpose of this formula, that depending on the value of R and C, you can create different frequencies. Is it okay? So as discussed, out of the three, we will discuss only one, this one. Now we will go to another type of oscillators. What is another type? LC feedback, the one we discussed in the beginning, tank circuits. Now, as we have discussed earlier, that we can use RC feedback oscillators up to 1 megahertz. Okay, but for higher frequencies, what we will use? We will use LC feedback. Clear? Now, in case of LC feedback, these are the oscillators. How many oscillators are there? 5 oscillators. Clear? But again, for us to discuss here is Colpitts and Clapp. In fact, all these oscillators are used, but we cannot discuss everything in the subject, so only we have discussed these two. Fine. Now, what is Colpitts oscillator? This is the circuit. Okay, the Colpitts oscillator. This is the amplifier. The purpose of amplifier is to compensate for the losses, and the frequency depends on this circuit. And this is the formula for frequency, 1 by 2 pi root of square root of LCT. Now what is CT? CT is because of 2 capacitors. This is a formula. So you have to know this formula. Okay. Any questions? Another oscillator is Clapp oscillators. You have to know the circuit. In fact, there is a solution to calculate how to know the frequency, but it will be very lengthy and it is not in the scope of our discussion. But if you want to know how you get this value, then there is a solution present. If you want, you message me, I will tell you from where to get. But for you, what is important? The value of the frequency that you get from these oscillators. Okay. Similarly, another oscillator is relaxation oscillators. So far we have discussed RC and LC oscillators. Now, why we go for relaxation oscillators? Here is the answer. Can anyone read and tell me why we use relaxation oscillators? I want someone to read this and tell me why our relaxation oscillator is different from other. Yes, all of you, you are there. I want someone to read this for me.
Yes, doctor.
What? Yes. What is there on the screen? This circle.
Relaxation oscillators. The second major category of oscillators.
ما في كامل. اقرا تحت يا محمد يا سلطان. ريد اقرا هذا بس ما في كامل.
طيب دكتور. Relaxation oscillator are used to produce non-sinusoidal waveform.
Jazakallah khair. I want everybody to clap for your friend Sultan. Thanks.
Welcome,
So,
Doctor.
yeah, Habib, you cannot clap also?
Myself.
Sultan, you are only clapping.
Yes.
No problem. Jazakallah khair. I like this type.
2 marks, huh?
No marks. You are not a business. Are you a businessman? Khalas, khalas. Let us discuss. So far, all the other oscillators, they were used to give you sine waves. You know sine waves? All the earlier oscillators were designed to give you sine wave. But sometimes you required something else. For example, in computer, you need clock pulses, square waves. So for that kind of requirements, you will be using this relaxation oscillator. Is it okay? You understand the difference between RC, LC and relaxation? Very simple difference. Anyway, so here we are. The first relaxation oscillator is what? Triangular wave oscillator. Do you know the meaning of triangular wave? The output signal will be like a triangle. You know the shape of triangle or no? So what will be the input for this oscillator? Who will tell me? For relaxation oscillator, what is the input? In input, always there is a DC voltage. Like we have got op-amps. Huh? In op-amp, we put VCC and VEE. You know this, right? So this is the only input that your circuit gets. And what you get in the output? A triangular wave. And how much is the value of frequency? This is the value of frequency. Now what is C? C is the value of this capacitor. What is this R1? The register that you can see on the screen, R1. Similarly R2 and R3. So if you want different frequencies, choose different values of R and C, and you can get the circuit for your required frequency. Is it okay? And this is the circuit. Now in case of your relaxation oscillator that we have discussed, this is the output. Fine. Can you see this triangular wave on the screen? Another last topic for this slide, this chapter is 555 timer as an oscillators. Have you heard anybody among you this oscillator, because it is a very famous oscillator used in practical circuits, maybe in mini project you have used. Anybody knows this? This circuit is like a chip or IC. You understand IC? This is a very small but very efficient and very much used, and it is used I think more frequently than others we have just discussed. So this is a 555 timer, and again in this 555 timer you are giving input signal what? This VCC, and what you will get in 3, in pin number 3 you will get output frequency of your value. Fine.